Hello developers, let's start developing. My name is Veko and today we're taking on the 21 first task out of the 2024 Advent of Code. First of all, some good news. I did manage to find the error that I had in yesterday's task, and to be honest, it was a relatively simple error that was here because somebody didn't read the description close enough. So yeah, that's usually my superpower in solving tasks, that I'm able to read the description and focus on it, but this time I didn't do that. Well, it happens to the best of us. However, let's take on day 21. And here we also have some good news, bad news. The good news is it's simple. The input is almost trivial to parse. Whatever we want to do, we basically have a keypad that is in front of a locked door and we need to press a sequence. The sequence will be something like 803A. So we press on the 8, move our finger to the 0, move our finger to the 3, move our finger to the A, we're done. Basically, it's a 3-digit code followed by an A, when the A means activate or something like that. That's great. Only the area outside the door is totally depressurized. Of course, we're in a spaceship, a reindeer class spaceship specifically. So we're gonna send a robot. How do we control where the robot finger is? Of course, we have a special keypad that we can control the robot. The directional keypad has 2 rows of button, that one, so it basically has 4 directional controls, and it also has the activate button. That's great. So we're just gonna tap on this to position the robot finger, click on A. When we click on A, it activates the button. That's great. That's the good news. So yeah. So if we want to type 029A, we will, initially it's on A, we're gonna move it over to the 0, then press A, then move it up and press A to move to the 2, then we need to press 9, which means go this way or this way, doesn't really matter. And then we go down to the A and press it. That's great. However, that directional keypad, this one, is in an area that has an extremely high level of radiation. We cannot go near it. We need to have a robot. So we have a second robot that controls the first robot. So we have one robot, two robots, and of course the area when the third keypad is in a somewhere where it's minus negative 40 degrees. To be honest, at this point I would rather stand the cold. But we actually sent yet another robot. So we are in the fourth area that is currently full of historians, so we don't have a robot for that. We're gonna have to do it ourselves. So what does this mean? That we have a directional keypad that has a directional keypad that has a directional keypad that has the actual keypad. So we have 4 keypads here. And we type on our first one, we're moving the third robot's hand. The third robot hand moves the second robot's hand, and the second robot's hand moves the first robot's hand, and we get something done. Yay, that's it. Not confusing at all. So even if we have this thing, we will need to basically see how we can do them. And of course, we need to find the minimal way. So I'm gonna start by, of course, we can start by reading the input, but reading the input is kind of trivial. I only gonna use this for the demo, for testing, because it's enough. And yeah, it's totally enough. We have string array. So we get this whole thing. Of course, we're gonna split it. Can we split it here? Yeah, let's split it. So instead of a string array, let's have a string matrix. Actually, this is an array of string of characters. It's not a matrix in the sense that different rows don't have any kind of connection. So we're just gonna return lines.map, and for each line we're just gonna split it on everything, so we get all our inputs. Let's just write it in to make sure that we already have what we want. 0 to 9a. Yep, we got that one. So now we have to find a way to actually press it. We need to model this keypad, and we have two keypads to model. So what I will do, so I'm gonna do something that I don't do very often, but I think it might be useful in this class. So let's create a class called robot. And that robot will have a constructor where we put in a keypad. Let's have the keypad be something like this. We'll think on it. So right now I don't really care what the keypad type it is, only that it is a keypad, and we're gonna do something like that. So we're gonna need to have we can have it even like this, we don't need this, and we're gonna have the position. So any keypad will have an A button, where the activate button when we are initially. So we're gonna need to find where the A button is on the keypad, but on the other hand, so we can have it like this, maybe. We can have the keypad like this, and we have the position. We will definitely need a position, which is a point. Because we will treat the keypad as a matrix. So this position is not this, but it's gonna be the position of keypad, this dot keypad of A. So this is not gonna be a string, but it's gonna be a point. So we're gonna have to have directions which we're moving. So type direction is gonna be not like that, but let's use it like this. So we have those are directions. So let's implement actually four methods. Move up. Let's see. So if we have the keypad like this, we're gonna need to find a button that has the same. We're moving up, which means we're increasing our Y. We're lowering our Y in this case because the coordinate system is like that. So when we're going here, we're closer to the Y equals 0. So Y becomes -1. So on the keypad, but yeah, I like the keypad like this, but I will also have this as well. have it as an empty thing. We want to reconstruct this. And since, yeah, let's have it like this. Not like that. For each element of key of the keypad, in, and this is the key that we want. Maybe it's better if we do it the other way around. So yeah, let's have this as a string array. And this will be a keypad map, which will be actually a record of a string and a point. So we're gonna use a double for loop until the width and the height, and we're just gonna fill the key map. Yeah, this is gonna be easier. So this keypad map of A. But we're gonna need an if statement here because we want to somehow model this thing as well. Because note that this is forbidden territory. If we get here, we should throw an exception. Also, this is forbidden territory, so if we go upwards from 7, we also get an exception because the robots kinda are weird that way. If a robot ever aimed at a gap where no button is present on the keypad, even for an instant, the robot will panic unrecoverably, so don't do that. So we're not gonna do that, but in order to not to do that, so let's see the keypad map of undefined. Yeah. Yes, we'll use a dot for that. Now we can also add a print method that will write out the keypad and the keypad map, why not? Let's have that. So this means that our robot of not of the input, but let's model this keypad. First is gonna be an array of exactly this, only in the different way. So we're gonna have this, then this, oh, copied it wrong, then that, and we have our A here. New robot with that specific keypad, and then robot.print itself. Let's see if we are making any sense. I'm not sure we are. So we have 0, 1, 2, 3. 0 is X 1, row 3, row 2, and so on, and then we have that. We don't have a dot, so we have 10, 11 things here out of the 12 that we gave it, so the dot is successfully stopped, yeah, and that's okay. So now move up becomes simple. If this position, yeah, let's create a new position. Since we only have the x and the y, this is kind of an overkill, so I will say that x is this dot position x, y is less than 1, and we will check whether we have something that's there. If new position and we have the keypad on the keypad. Where are we? Yeah, something like this. But we will also need to check whether we are, yeah, since we're only moving up, we can say if we know where we are. If the y is 0, then blow up. And we don't have a problem otherwise. So yeah, in this case, we are allowed to have some. Do we need the keypad map? Maybe not, I don't know. But we can also have the current key, which is a string, and we can say that the current key is A. So now, if we are not on the 0th row, of course we can move up, which means we can get this dot position is equal to that thing, and we can change the current key. And we're gonna have move down. If we're at the last part, we cannot move down, which means if we are here, we cannot move down definitely, but additionally, we can not move down if we are on the 1. But we can actually use that. If this dot current key is equal to 1, since we're using actually letters, the current key will always be a string, cannot move down. Otherwise, move down. Move left. We can always move left except if we are on 1, 4, and 7 and 0 as well. So we need to do that thing here. If is 0, cannot move left from 1, and let's down from this current key. Let's add it here as well, so we're consistent from current key. Oh, we're only modeling this keypad. That is why I needed the key map. So yeah, this makes sense, but we cannot use this. We cannot move down. We also need to check Let's do it this way. So, yeah, this check is definitely needed, but we will also need to check whether this thing exists. Since we're checking y, we can say if this dot, and we're gonna abuse a bit of JavaScript right now. Since we know this exists and we know this exists because it's not zero. So if that thing is a dot, we're gonna have to do this. Otherwise, that's the new position. And if it's a dot, we cannot move down. And now we have a much nicer format of all of this. We're going x minus 1 if we move left, and if we're moving right, we're going x plus 1. Yep, seems okay. So let's have it print the position as well. So now it will say that it's on position 2 and 3. No, I don't care about the position, to be honest. I care about the current key. It should be on A. Yeah, so from A, if we want to move up, we should get, let's try to walk our robot around. So from A, I don't want to go from A to 0 to 2 to 1 and go down. Let's see if that works. Let's change this thing a bit. Actually, let's have it print key, which only prints the current key. So we're gonna have a robot, have the robot print the key, robot dot move left, print the key, move up, print the key, move left once more. So it's over the 1, print the key and move down. And why not print the key? If everything goes okay, we should get a blow up. Not really. We have A's and we have 3's. It went up correctly. So when we moved left, we wanted to go to 0. So when we moved left, I don't know what happened. Let's see. X is 1, Y is 3 when we moved left. Yes, that is correct, and we shouldn't get an A, we should get a 0 over there. Did we forget to update the current key? Yep. Copilot. It's not Copilot, it's us, because I should have noticed that we only did all the calculation and none of the work. But yeah, let's see if it goes well now. Oh, it went great. So it went from the A to the 3. And then it went from the 3 to the 6 and from the 6 to the 9. Because I am kinda silly. This code is not supposed to be this code. This code is supposed to be new position. Go to the new position, no, not to that one. And then refresh the current key. You know what? Current key and positions are totally correlated. So I'm afraid that if I continue working this way, I might get some other places when I have an error and I only set the position and don't set the current key. So what I will do, we don't need this. I'm gonna have it like this. Actually, we can have it. What was the correct syntax? I want to have it like a property. Something like this. I don't always do this, but when I do, I'm gonna ask someone smarter than me, that not smarter than me, someone that is much dumber but has a much better grasp of syntax, how to define a property in TypeScript. This is my favorite AI that I oftentimes use to actually get a sense of how the syntax was like, because there are just so many languages with a lot of syntaxes, and of course it was like this. So it's gonna be get, and after this I was missing these parentheses. Now that I have the parentheses, I don't need the equals, I don't need this, I don't need this, I can just do this. And if everything is okay, I think that I can even do this. Not yet, maybe in the next version of TypeScript, but for now we can have this. So right now what I did, I exchanged current key. Instead of having it as a value, I have it as a function. And each time that I say give me the current key, it will just run this function. So this might not even need to be private, I can have it as a public thing, since it's only a getter function that we can use. Let's save this and let's run our code, and hopefully we're not gonna continue going up. So now we went to the 0 and then we went to the 2 and then we went to the 1 and then we went down and everything blew up. It says cannot move down from 1, which is correct. Now let's reuse this because we're gonna need to have another robot. This robot. So yeah, let's call that robot 2. Robot 2. So that is gonna have a dot first, then a upwards thingy, move up, and then an A, and on the bottom, that's the top row, and the bottom row is exactly that. So we have our arrows. Robot 2 is that, robot print key, so we're on an A, we're gonna move it left, we're print keying, we're gonna move down actually. So print key, we should be on this position. Let's move left once more. That's gonna be on the left arrow and print key, and let's move left once more. Let's try to move to the empty area to see if this thing will blow up. But in order for that, we're gonna need to comment this out, otherwise we will blow over there. So we're staying at the 1 position. So we made some error, I think, because we went up, then we went down, then we went left, and then we wanted to move left from there. No, we don't want to move left, we want to move up, which is also illegal. and we cannot move up from the left one because that one is empty, even though we have that place in the array. So this thing actually exists, but we cannot go there, because if we go there, we panic. So, okay, we have our keyboard, we have our robots, and we can move them. And now we want to somehow connect them. So let's start with this first robot. So whenever we press a button, I will also give it an action method. That's gonna be a function that will take, yeah, this robot. No, it will take the current key. And do nothing. Return nothing. Just do something. For now, let's just have it, but each time we do something, so this is moving, but we will also have a press key method, which doesn't take parameter. We're pressing the current key. And what we will do, we will basically code the action with the current key. So for the first robot, our action will be simple. We're taking the key and we're console logging it. So what do we need to do for this robot to run this code? So we wanna do something. We want to move our robot according to some sort of thingy. Let's see if we can actually get it to press this thing. So I think we might be useful. So I have no idea what I'm writing. I'm doing a lot of exploratory development right now. So I want to create another, I want to do exactly that. I want to have this move method that will take a direction, and depending on the direction, move the robot in some certain way. We can do it a lot better, write that code a lot better. But so if I say const directions is gonna be something like, I'm gonna take an array and let's see what we need to do to actually move our robot. I'm gonna add another case A, press the key. So this will be a direction or an A. So the directions will be, we're on our thingy. We want to have this specific thing. So now this is totally hard-coded. We want to move along and see if it will press. So we will need to go that way from the A and then press it and go to the 2. We're going up and then we're gonna press it, and then we need to go to the 9 it says that there are actually a few of these thingies. That are the shortest one, and that makes sense because we can get to from the 2 to the 9 in quite a few different ways. So we can go up, up. We need to go up 2 times, we need to go right once, so we can go right and then up, first up, then right, then up, two rights and an up. I'm gonna choose for now with the two ups and then a right, and then we can press the 9, and then of course we go down thrice and we press the button. So for each direction of directions, robot move that in that direction. We can say this is a special kind of string. And since we're gonna press some buttons, we might also get some console logs. So it's not so much move as it is execute. Yeah, let's just call this execute. Let's run our code, and if everything is okay, we're gonna get 029A. Yeah, that's great. So, and if we have the other options that we have here, that if we do this one instead, we're just gonna get the same thing. 029A. So now I like this one better. So now we need to attach the second robot to this whole thingamajig, because we don't actually have this. What we actually have, let's call this numeric keypad, but we will also need to have directional dir keypad, and that's the other keypad. Let's know it's a dot followed by an up array followed by an A, and that's the first row, and the second row is hopefully auto generated. Yep, it is. And then so this is robot 1, and then we have robot 2 and robot 3, which also has that, but robot 2 won't have this thing. Robot 2 will have a special thing that will connect it to robot 1. So now, whenever we do something to robot 2, it will actually transfer that to robot 1. So the action that we do when we press a key will be robot1.exec that key. And of course, we're gonna do the same thing for robot 3. So let's just see a bit. So this is a sequence that we can execute on the second robot. Execute this on the second robot. Only the first robot can print. Let's see what happens. 0298. So we're executing our directions on the second robot. The second robot executes them on the first one. So let's take another one right now. Let's try this one. And since this is the long one, we're gonna actually execute it on the third robot and see what happens. 456A. Let's see if that was what's supposed to happen. So 1979A. This is a bit longer sequence. 179A. So we solved the wrong part of the problem so far. I will pause right about here because it is a fun problem and I think that we made a lot of progress. But so far we were able to model the program going forward. Now we're gonna need to work back. I still don't know how we're gonna do that, but for now we have our robots that are connected in such a way that if we give a command to the third one, it will give a command to the second one, which will give a command to the first one, which will actually do the thing that we needed it to do. So all of this is great so far, but we don't have a solution. Anyway, if you like the effort so far, click like and subscribe and keep developing.